Okay, this is one way. Okay, this is called journal queries. Now I'll let you know about. Okay, I'll delete all these things. So there is one more situation. Suppose a query will come. Okay, sorry, data packet will come. And when data will hit, there is, when I am sending a query after 60 seconds, okay, periodic update is 60 seconds, right? No user is participating. I'll let you know what I'm trying to say. We have to analyze these. Okay, so now when data stream came, no user for a particular stream. Then what will happen? Then this IGMP router will do, this IGMP router will send something called IGMP query with a source IP of router. I'll try to understand the difference between the previous packet and now. Destination will be all host. Now, before it was asking, do you want to join any group? But in group specific query, he's saying anyone wants to join because data stream came. So he's asking anyone wants to join 239.1.1.1. This is called group specific query. Okay, so there's a difference. Journal query means after every 60 seconds, like a periodic update, I'm just sending, okay, I'll show you practically also that you want to join any group. But that is another condition is when data stream will come, okay, user is there, send. But if a data stream will come and no user is there, then group specific query will come in a picture. So for that specific group, I will ask everyone, do you want, and last time I'm asking, do you want to join this group? It's a kind of a thing. Okay. So that is the first thing you need to understand. What is the difference between group specific and journal queries? Now, next part. Now we have something called suppression mechanism. A lot of small things are there. Let me clear this out. Another concept in IGMP is report suppression mechanism. Now, problem is, I'll let you know. If suppose this is a router, which is my IGMP router. Okay, and this is the host. Okay, now when he's sending a query that do you want to join anything, any group, the PC1 is saying I want to join this group. Another PC is also saying I want to join this group. Suppose PC2 and PC3 or PC2 and PC4 are saying I want to join this group. Means everyone is sending a join message. Suppose we have 1000 users. Now 1000 users will send you a join message. So if suppose they have a list in the IGMP query, when you will check the table, 239.1.1.1 PC1 is also learning, PC2 is also learning, PC3 is also learning, PC4 is also learning. This will, in this scenario, too much CPU memory. It will take too much of CPU. In this scenario, you will notice if everyone will send a join message, too much CPU utilization, and if every entry I will going to put in my IGMP table, too much of memory will be wasted. So with that context, they come up with another concept called report suppression mechanism. Now actually what will happen, now try to understand, explain. Okay. Now when this guy will send a query, see, this guy will get a packet and this guy will get a query, there will be a delay, right? It doesn't mean that everyone will going to get in similar, like simultaneously. Maybe there's a delay of 2 seconds, a delay of 1 second. So now out of this, whosoever will get the first query, this guy will try to send a packet of join. Join source IP will be my PC2 IP. Destination IP will be I'm sending to this guy. And I want to join 239.1.1.1. Right? Now try to understand, there is a delay in getting query to the PC, right? So whenever you will get the first, it will respond. Now, as this is a multicast address, so this query, now you need to understand, change the color. This particular guy who's sending a query, it will go to here also, here also, here also. Now see, we need to understand that this is a multicast address, it will go to all the PCs right now. Okay, so what these PCs will do, they will see, this is how they are going to understand that someone has already sent that they are joining 239.1.1.1. So if they are also sending join message for same group, they will go into back off. Simple concept. Concept is because it's a multicast packet. First of all, I will send a query. Query won't reach out to everyone simultaneously, right? There will be some delay. Okay. So whosoever will going to respond first. Okay, that response will go to everyone. Now everyone is preparing their join message. Suppose all are listening. Once all these will going to get the join message that okay, in our group someone has sent a join message, they all will back off. Okay, and one more thing, in this way you will going to reduce the CPU when they back off. And here in IGMP only one entry will be there. It is sufficient, which is written at last response. After every 60 seconds this will happen. So that 239.1.1.1 PC2 was the last guy who responded. Now he will going to test if a query will come. Now any data packet will come. Okay, I am not concerned that how many PCs are listening. I am just concerned that in this particular area, okay, someone is listening to 239.1.1.1 and then I will send a query. Okay, so after every 60 seconds, it will send a query. Anyone has to reply, otherwise delete the group. Okay, now again one more thing. If suppose no one is replying, then it will delete the group also. That is called leave message, meaning that I'll come to the next point, will be a leave message. See, I'll just make a note what I have explained right now. There is a delay in getting query, okay, to the PCs. So whosoever will get first, it will respond. And if I have told you when it will respond, and if other devices are also running on same multicast address. Okay, and if they will see the join multicast stream of the same address which is also listening, okay, then it will going, then they will going to back off. Then they will back off. Back off meaning they won't send a join message, because there should be one representative out of you all who is sending a join message. Okay, because we do not want a lot of join messages, it will increase the CPU. Second thing is only single entry we require. Okay, and there is something called a response timer also. I'll just make a note. Response timer, which is called 10 seconds. What is the meaning actually? Within 10 seconds, if you have sent any response after that, see, my query timer is 60 seconds. After every 60 seconds, I will send a query. Okay, once I will send a query, there will be a 60-second gap, right? But we have something called response timer 10 seconds. Within 10 seconds, if you send a response, fine. After 10 seconds, if you will send, it won't accept. Okay, maybe someone else can send a replay attack. So that we do not want. So just make a note within, meaning once you will get a query. Okay, now it will wait for, like, your IGMP router will wait for 10 seconds. If no one will respond within that 10 seconds, after that, if anything is coming, it won't accept. That is called response timer is 10 seconds. Okay, then again when new query will come, then again he has that 10-second window. Okay, one thing. This is called your report suppression mechanism. Another concept is called, in IGMP, we have something called leave message. The leave means if for my 3 consecutive query, 60, 60, 61, 80, you are not responding me, and I have a group here written for you. See, now try to understand. Once I will write that 239.1.1.1, suppose PC2. If suppose you are not responding me for, see, again after 60 seconds, after learning you that you are learning this stream, after every 60 seconds I will going to send a query message. If for 3 query I won't get any response, I will going to remove group. But here the problem is 180 seconds, which is called 3-minute delay, which is not acceptable. So actually what they did, they come up with a concept called, if suppose you want to leave also, before there was no leave message, now they have. Now try to understand, PC2 was listening. Now suppose here this guy is saying that leave message. Now when leave message will come, issue is it will delete complete group. When a leave message will come, okay, it will delete the complete group. That's why what will happen, once a leave message will come, this guy will send again a concept of, you just recall it, group specific query. That someone has sent me a leave message, because I have only one entry, I have to delete that. But if anyone else still they are listening to this, because try to understand with the report suppression concept you have seen, I'm not going to write 100 entries, I'm going to write only single entry. If someone is sending me leave, meaning I have to delete this group. Leave meaning is delete the group, but I do not want to delete. So what I will do, I will give one chance to the user. I am sending a group specific query. If anyone will say join, you can join it, otherwise delete. Okay, this is called your group specific query. sorry, within a leave message, how to use group specific query second way. One I have told you in the data message, one is this way. Another concept is, what if multiple routers on a network? Which is called a query. Okay. In this scenarios like this, see, I have two IGMP routers. Okay, R1, R2, and this is a switch connected in between, and we have this. So when an IGMP router receive a journal query, what will happen? This guy will send a query here. This guy will send a query here. The router compared the address in the message. See, now try to understand. We can send query out of only one router, and I have two routers. So actually what happened, when this query will come, this query will go here, it will go here, it will go here, and it will go here also. Okay, when this guy will send, this will go here, this will go here, this will go here, and this will go here also. They are sending a complete packet, right? Now router, now here only the election process will start. See, try to understand, first of all, only one guy can become a querier. One querier we need. I'll put an important point. Then when they are sending a query and they get each other queries, then your election happens. So after election, one will become active, one will become standby. So after, make a note, after election, one will be active, one will be standby. Now who will be active, who will be standby? Okay, when they will compare the router with the lowest IP address on subnet elected as the IGMP query. Okay, the router with the lowest IP address on the subnet is elected the IGMP query. Okay, now that is like one is decided, other will be standby. Now what is that timer? Now try to understand, suppose this is a standby and this is active. Now query is also coming. Try to understand, he's sending a query which is going here, 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 and it is coming here also, but he's just receiving the query. Now, what if this router fails? Now, if he won't listen the query, R2 won't listen a query for 120 seconds. So that timer is 120 seconds. It's like a switch concept. Like if you won't get a BPD for 20 seconds, I will come up. Same thing for 120 seconds. no one respond, standby will become active. So that 120 second other standby router is not listening query. Within 120 seconds, the other router will start sending queries. Now then this guy will start sending queries. Okay, this is how your IGMP works. So if I will summarize, we have different version of IGMP. We have version 1, we have version 2. I'll say version 2 and 3, and few things which are only there in version 3. Now in version 1, when I talked about journal query, we have in version 1, but we do not have a group specific query in journal 1. Okay, and then we have a leave message which is saying that 3 times he will going to send and then he will quit. It doesn't have that concept of group specific leave message. Now in version 2, you have journal query concept also and group specific query also. Here we have a concept of router max response 10 seconds. That concept, suppression 1. It was not there in your 1. Responder 10-second concept. Other is we have leave message. 1 is what I have told you, 3 queries. If you won't do, I'll quit. Other is if I am sending a leave message, you will send me a group specific query. Okay, version 3 has something called source specific multicast. In last, I will show you this practical. Only version 3 has this concept, source specific multicast. Meaning hosts are very much clear what is their source also. Multicast address, what they are listening, see, it is like this. Client is saying that I want to listen from this group, but server IP should be this, so that no one can send you a stream. Okay, it's like a URPF only, but kind of a concept. So I want this multicast stream from 1.1.1.1. So the last point was I was writing, we want this stream from specific IP, which is 1.1.1.1. Okay, that you just write it under version 3. Okay, so this is right now about IGMP. Okay, so what we have done, we have seen journal query, group specific query. We have seen route suppression and that query suppression. Okay, and then we have seen leave message. We have seen 2 queries are there who will become active and standby. And then I segregated what is there in IGMP version 1, version 2, and version 3. And next thing we need to move towards multicast routing. When I will start routing, and I will explain you, we have dense mode and sparse mode. Okay, so at that time when we'll do practical, this IGMP practical will be covered inside that practical only. Okay, practicals are easy, just one command you need to type. It's fun, like 90% theory here. You need to understand. Okay, so today I'll stop here. Tomorrow I'll start with the routing part.